Right. Thank you, Nicholas. My name is Gregor, and I've been exploring coding with AI a lot lately. And I want to share some of the things that I learned. But before I go there, I would like to start with a small story of how I started my career as a software developer. Because when I first started, I wasn't very good at this. My code was crap. It was like spaghetti code. And the customers, they were the worst. Like, it was only when you first showed them a first version is when they really understood what they need. And then, of course, they wanted to change it. They wanted to change everything. And I had to change it. But it was very hard to change. It was not fit for change. And I struggled. I suffered. And eventually, I got a better feeling of like what changes a customer would want. And I learned about some technical books, about design books, and I read into some design books, and it helped me improve and helped me write better code and code that is like more fit for change. So that was an improvement, but it still so happened every once in a while that I ended up with code and a customer that wanted to change. I could not easily make that change. It was too hard. And I again struggled. And back then I didn't have an idea about TDD and refactoring. Like it was just design, which I know some things about. And I knew that I had to improve this code. But at work, nobody cared about the structure of the code. Nobody cared about the design. Everybody only cared about whether it works and whether it's finished in time. But I knew that in order to change it, I have to first improve the design. I have to first improve the structure. It's too hard right now. It's too risky right now, even. And so I thought I needed a safe space where I can sit with the code on my own terms and in my own speed to work slowly and try to improve the code. And this safe space, I didn't have this at work. They wanted it yesterday, and I couldn't simply work on the code for, let's say, 2 days and then potentially get nothing done. Like, what do I tell them? Do I tell them, "Oh, I'm working on this code for 2 days, but I didn't change anything because I failed improving the structure"? So this kind of improvement of the design was also risky and scary. So I needed this safe space. And so I took the code home. And I worked at home on the code in my own speed, slowly, methodically, and I would learn a lot of things doing that. And sometimes I would succeed. Even when I didn't succeed, I would learn a lot of things. But when I succeeded, I came back to work, and work then was a breeze. It was easy, and I could make the changes the customer want, and everybody was happy, and I was happy. It's just that I shouldn't have had to. I shouldn't have felt like the urge, or there shouldn't have been this urge to take the code home to a safe space. It should have been possible to do this at work, or I should have felt confident to do this at work. But only later I learned about refactoring and about test-driven development, which eventually gave me the confidence to change the structure of my code whenever I wanted safely. And this changed everything for me, at least. So in November 2023, GPTs came out on ChatGPT. If you don't know those, they are like agents that you could build, and they would run in the cloud, and you could share them with other people, and other people could run those GPTs and try them out. And those GPTs, they could also run, like write and run Python code. This was awesome. So of course I had to try it. And I built a software crafter GPT back then. It could solve little katas, like coding exercises. It could do them pretty well. It would follow strict test-driven development. But back then I didn't know anything about context engineering, and everything would only happen in like one chat window. And eventually like the chat would get longer and longer and longer. And as the chat got longer, the context increased. And at some point, it just started doing bad. It stopped working well. And this was the system prompt back then for the software crafter GPT. I had no idea back then that this would be something I have a lot today. Today, I would call this like a process file. I have in the top, I have high-level intent, and maybe I have some rules, and I have workflow steps that I want the agent to follow. Later in February 2025, this guy, Andrew Carpathy, he came up with the term vibe coding. The idea was that now LLMs are so good that we could just go with the vibes. We could just prompt something and let it write code, and then just live with the code, take it and work with it without even caring about it, not even looking at it. So just vibing it. And this sounded strange to me because it was only when I cared about my code, I nurtured it and I improved its design, I cared about the code quality, was when I was able to sustain the development and I was able to make the changes the customer needed. So this vibe coding thing sounded really strange to me. And I think it's something that we have been doing like for quite a while, and it hasn't worked out so well for us. Later in May 2025, Kent Beck came up with this term, and he called it augmented coding. And he described it as a way to, yes, work with agents in coding, but also care about the code and its quality, to care about tests, and to eventually be sustainable with doing it. And this resonated with me. This sounded more like what I wanted to do. And it was also like around the time when Claude Sonnet 4 came out, was when I wanted to try it again and do another deep dive in the large language models and the agent space. And this was around the time when this came out. Why this sounded, why this resonated with me is like, because I think that in software engineering, we are managers of complexity. Or can we even manage complexity? Maybe we can only navigate it. I think we are like managers of complexity before AI. We have been managers of complexity. We are also now, after we have AI, we're still managers of complexity. And our goal is, or should be, to keep systems as simple as possible and fit for change because of cognitive capacity. We can only keep so many things in our head. And when it's simple, it's easy to change. And turns out AI also has this limitation in cognitive capacity, so it also works better with a simple and clean code. So it's another reason to keep it simple. So we cannot just ignore the code. So when I started to try and make this deep dive in coding with agents, I had to choose a project I want to work on. And I thought, wouldn't it be cool if we had an agent that you could give some piece of legacy code and it would take this legacy code, it would characterize it, it would break hard dependencies around the boundaries, and it would write characterization tests for on this code, and then would start refactoring the code autonomously, and then you would eventually solve the problem of legacy code. Wouldn't that be awesome? And this is the thing that I set to solve. Of course, I had no idea if I could succeed, if this was solvable, but it sounded like a fun challenge. And implementing the code modernizer, I thought I needed refactoring tooling. And so I ended up building refactoring tooling by the agent for the agent. And that was quite fun, but I had to have some principles that I would follow when I build this with agents or with an agent. And the first principle for me was Poka Yoke. Who of you knows Poka Yoke? If you know it, please write it in the chat. I have the chat open. I can read it. I'm waiting a few seconds. Okay, so I don't see like an answer coming in. Some nopes. So Poka Yoke comes from lean manufacturing, from the Toyota production system. The idea is to design the system in a way that people cannot get it wrong. Nobody can get it wrong. You know this? Yeah, it's USB-C. So what is great about USB-C is you could put it in both sides. You cannot get it wrong. It's kind of Poka Yoke. And I thought I have to design the system where I'm building with AI, the code modernizer. I have to build it in a way, I have to do it in a way that the AI cannot get it wrong. I think like blaming is for the lazy. Of course, doing this, I had to write the tests first. Not like all the tests, but like one test at a time. TDD, test-driven development. Because obviously, if I can write what I want in the form of a test, then this is the most precise way I can define what I want for the AI. And then there is no way it can misunderstand me. And those tests would be my executable specification. I would have everything covered with tests. I could keep run them all the time, and they would be very fast. And I also needed to solve one problem at a time. So I had to break apart big problems into small problems. And I did this with AI, and I noticed that AI is not really good at breaking apart big problems. AI really wants large batches. So I did things like take one problem to solve, and then I would ask it to decompose the problem into smaller problems, and then order it by simplicity, ascending, and then I would take the first problem because it was still too big, and I would have it break it apart again into smaller things, and again sort it by simplicity ascending. Then I would again take the first thing, and it was still too big. And then I used TDD zombies. If you haven't heard about TDD zombies, I recommend Googling it. It's a nice way to find small problems to solve in a bigger problem. And I needed to always keep the code working. Like I would write one test and I would implement that, and then I would make sure it works and that everything keeps working, nothing breaks. And whenever something breaks, I would revert it. So I had those principles, Poka Yoke, small steps. I would give feedback to the AI in form of tests and others like test-driven development. But I also wanted to aim for higher autonomy. And I did some things with my rule files and with my process files that I would like to share with you. First of all, I used starter symbol. It's a trick I learned by Llewellyn Falco. Is I have these two lines in my rules file, and it gives me a lot of information. The problem I'm solving with these two lines is I'm basically asking AI, hey, are you still with me? Because when the context gets too large and it starts forgetting things because of that, eventually I might stop. I might not see this starter symbol anymore. And also I would choose different starter symbols for different steps or different phases in the process. And I would have lots of process files. The process file would look like this, similar to what I showed you, like the system prompt for the software crafter. I would give it a starter symbol, high-level intent, some rules, and also workflow steps. The agent should follow in order. And I would really evolve those process files. I would invent a feature, not for the sake of implementing the feature, but for the sake of enhancing the process file. And I would run it, and I would drive it and create some code using this process file. And I would see, like, does it work? And eventually I would throw the code away, because it's not about the code, it's about the process file. And when I found that something doesn't work well, or the agent would do something not to my liking, I would go back and I would expose this decision in my process file. I would maybe have another rule or another workflow step in the process file to make explicit what it should do in this particular case. And this is very interesting because, like, my focus shifted from technical details more to methodology, like what decisions to do and when, and also to make those decisions explicit. It was like a learning process for me, because there were a lot of implicit decisions that that I do, that are not explicit, and now I'm forced to make them explicit. It was quite interesting. And when I kept adding steps to the process file, eventually the process file got larger and larger and larger and larger. I had more steps and more rules. And the more rules I had, maybe some of them were contradicting, or it would omit steps in my workflow. It would not follow it to the fullest. So I had to find a way to make it work still. So I ended up splitting the process files. I was trying to find coherent parts in the process and put them out and define a new process file that is just about this thing. Then I would have many more smaller process files that are more focused, so that the agent, when it works over those process files, it's more focused on that thing, and it would do better. But when I had several of those process files, and for each of those process files, I would start a fresh context so that the context would stay really small, because like small context not only means cheaper, it also means it will work better. In order to make those agents that work on different process files be aligned, I had to come up with some sort of text markdown where I put all the relevant information that the agents would read in the beginning, so they understand what we are building here. What is the context? What are we building? What is this application doing? Maybe what is the high-level architecture, and what is the current goal, and what are the next steps? Something along those lines. And this is something like every agent working on a process file would read in the beginning, and then they were aligned. But when I had all those different process files and the agents would follow them, I had to be the man in the middle that would tell AI, okay, new context, and now this process file. Okay, new context, and now this process file. Okay, new context, and now this process file. This was boring. And I found that there is a better way to do this. And that is a sub-agent pattern. Is oh wow, I can tell an agent in the end of my workflow, I can tell it to call another or create a fresh context that starts with another process file, and it would do some other stuff. So I didn't have to be the man in the middle anymore doing this. So I could do things like a task chain where I could have things like one agent following the writer failing test process file, and then spawning another agent, and then following the make it pass process file, and then spawn another agent refactoring. Okay, and if I had like a task chain like this, I could also run it in a loop. Why not? Why not run it in a loop? And it would run and run and run. But the thing that annoyed me was that, like, I really wanted small context. Context is key. And each of those agents, they also had the responsibility to delegate to the next agent, to the next process. So not only would they do their task, they also had to delegate. And this responsibility of delegation was unnecessary in the context. And doing it this way was also not quite resilient. Like if something went wrong and I had to stop, I didn't know where to continue now. Where was I? Yeah. So I found a way. I could extract an orchestrator and I could pull that coordination logic out. So I created another process file for another agent that would know when to start the writer failing test agent, when to do make it pass agent, when to do refactor agent. And this process file only had to know like when to delegate to whom, what information to give them, and so on and so forth. So it would take care of the loop, and it was much more robust. And it would also know where to continue in case I had to stop and break it. But I didn't stop there. Like with orchestrators, yeah, you can go on. You can have like a refactoring orchestrator, and you would, in the beginning, you would have it find something to refactor, and then in another agent, it would decompose this thing into smaller steps, and then it would spawn one agent per step and implement that. To have like really small contexts. And there are lots of other things where you can have an orchestrator for. And when this thing runs and runs and runs, and it can run for a long time. I remember I had it run for 2 hours. and it did 60 commits working on extract method refactoring in Roslyn. And I was inclined to walk out the door, go to the kitchen, open the fridge, and I don't know, do different things. And when something went wrong, maybe it stopped because there was not a clean git state for some reason, or some test failed, or the context went too large. Like I didn't know when to come back. So I needed a way for it to notify me. And I found that I could use some sound signal, or so it could play a sound, or you could even use text to speech. And I would have like workflow steps where whenever something went wrong, it could use this sound to notify me. But I don't really recommend Wake. What I rather recommend is staying there and holding the finger on the stop button. Because usually when I let it run for too long without human oversight, it drifted, and it did things that I didn't like. It found ways to complicate the code in ways I had never anticipated. It did over-engineering, different kinds of things. So whenever it got to the refactoring phase, I started having a bad feeling in my stomach, because it would usually do things I thought were not a good idea. And I haven't found a solid way to solve that problem yet. So maybe better than stop is something like checkpoint, so that whenever there is a good point in time where a small change was made, you could have a workflow step where it should ask you to review the code. Maybe that's a good solution. Yeah, this is the workflow I have defined so far, and all the steps in that workflow it's kind of long, but it's still not finished. It's still evolving. You can add many more things. It's just I kind of, since a few weeks, I stopped working on it because I had more fun building my own agent. And I might continue evolving this process. So things I learned building and evolving this process is, first of all, we want to automate, or I don't want to say automate, because AI is also automation. I want to say algorithmify everything that we can, to have everything that we can should be deterministic, that we can make should be deterministic. That means, like, we need a lot of scripts, we need a lot of feedback loops in our development process. Like I have scripts for not only running tests, I have scripts for generating code coverage, and the code coverage is output in a way that agent can read it well. I have a script that does mutation testing, and so on and so forth. Maybe you also have like a script for I don't know, linting, or giving feedback in terms of code quality, like static analysis, and endless ideas on how to give the AI feedback on what it should do better. And maybe also like refactoring tools. And when we write those scripts, please make sure that you take care about your standard output. I see a lot of people using their agent, and then they have their agent run the tests, and then the tests create like hundreds of lines of log output and written to standard out, and then the agent has to read all of that log output, and it contaminates the context. and it's unnecessary, and it will make them perform worse, and we don't need that. So what we rather want is like a wrapper script that swallows all of that log output and only prints like the necessary information to the context. Like all we want from a test script is like whether it failed or passed. When it passed, maybe like how many tests passed. And also when it failed, actually we only want the important part of like what failed and why it failed. We also don't need all of the log output when it failed. And I found, and this is a story that really happened working on a real product I'm working currently, is we had a customer incident where they reported a deadlock on the login system. And we analyzed it, and it was very hard for us to fix because there were architectural issues. It was not easy to fix, and it wasn't even easy to analyze. And it took us a lot of time to not find a proper fix. And in the meantime, more and more customers came and reported the same deadlock issue, and we had to find a way to fix it. The best idea we had was to just improve the architecture at this point, to make an architecture refactoring to fix it. I thought I have to try it with AI. Maybe it can help here. And so I took out my agent. I gave it all the information I had about this issue. I told it where in the code I know this issue occurs, the relevant files, everything I know about it. And I asked it, hey, please, Claude, fix it. And then Claude came and it read some files, it did some analysis, it did deep thinking, and then it said, oh, I know, I understand what the problem is, I can fix it for you. And then it went on and changed a few lines in some files, and then it said, deadlock fixed. Guess what? I tried it again, I reproduced the issue, and it was still there, it wasn't fixed. So I told Claude, you didn't fix anything, it's still there. And then again, it said, oh, I understand, I know how to fix it. And it read some files, and it did some analysis, did some thinking, and it changed some files. And then it said, now I have fixed the deadlock. Guess what? I tried it again, I reproduced the issue was still there, so it was not fixed. And I tried this a few more times, like also with fresh context, but we were getting nowhere. We were just running in circles, changing code in ways that don't help anybody. So I had to come up with a better way. So I said, let's do it this way. Let's not change any of the code. Let's come up with an hypothesis and then prove the hypothesis. And only when we have proven the hypothesis, then we start changing the code. So then what Claude did, it analyzed, read some files, and then it said, I have an hypothesis. And then it added some log output, log statements to the code to prove the hypothesis. And then it asked me to reproduce the issue. And I turned on the application, I reproduced the issue. There was the log output. I copied the log output, I fed it to my agent, gave it the log output, and then it said, oh, I have disproven my hypothesis. I was wrong, but I have another hypothesis. And it added more log output to different lines and different files. And I run it again. I reproduced the issue, and I took the log, I fed it back to the agent, and then the agent said, oh, I have proven my hypothesis, and I know how to fix it. And it made some changes in a file, and I was really curious at this point. So I started it again. I tried to reproduce it, and this deadlock was actually fixed. But there was another deadlock at a different position in the code. So it was now later, it was moved. And I told Claude, hey, you fixed the deadlock, but there is still another deadlock. And it again said, I will create a hypothesis and create some log output. I ran it, reproduced it, gave it the log. It said, I know how to fix it. And then it just took some disposal code that was around in this code base on a totally different place. I haven't even known existed in this really huge code base. Took it over, pasted it in, bam, it was fixed. The deadlock was fixed. So it turns out AI is really good at debugging. And it's a good idea to have it make hypotheses. By the way, when we write a failing test first, this is also an hypothesis. It's an hypothesis that the feature doesn't exist now. And I thought that's interesting. Another thing that worked quite well for me is, like, when I work with agents, or when we work with agents, we often tell it what to do. But we are not always right. And we don't know what we don't know. And sometimes we are wrong, or we are leading it down the wrong path. And there might be better options, better solutions. And the thing is that the AI has basically written almost all of the books and code on the planet. So it knows quite some things, and we can leverage that. And I noticed that sometimes I would rather ask it than tell it what to do, and it would give me surprising answers. I really recommend trying ask, don't tell. I also like to have it ask clarifying question in the beginning of my process where we define the goal, because it's really good at asking clarifying questions. This is another thing I learned work really well. So I work a lot with a legacy code. I like working with legacy code. It gives me a challenge. And often when I work with such code, it's not easy to test, but you still want to refactor it. And then you have to decide, do you now start testing it, or is that correct characterizing it, or do you just refactor, or do you do both? You have to make that decision. And sometimes you even have to refactor before you can write those tests. So I found out that AI is really good at reviewing my refactor commits. So the thing is, when I work with code, I have commits like this. I would separate the refactoring commits, the refactoring commits from my behavior changing commits. So whenever I do a refactoring, I only change the structure. I do not change the behavior. And I would have like a small r when it's automated, when it's very low risk, it's provable. And I would have like capitalized R with exclamation marks when I'm not sure if this thing works. And when I thought it was risky, it was manual, I could not prove it was correct. But all of those commits, they are rather small. Like they might only change 5 lines of code. They are very focused and made surgically almost. And I learned that when I work with AI on refactoring, I could make such a small refactoring step, and then I would ask AI to review my refactoring step. And and I would ask it to report if I change the behavior of the code. And if I did change the behavior, I said it should warn me. And I would do this repeatedly. I would make some small change, refactor it, and then I would ask it, review my change. And I would report back. And if it said, oh, no behavior change, I would commit it. And I would do the next step and ask it, did I change the behavior? No, you didn't. I would commit it. And then I made another change. And then it said, oh, change in behavior detected. You don't care about the case where it is null. And then I said, like, but can it really be null? Is there really any case where this can be null? And then it went on to find all the usages, and it turns out it found that it cannot be null. So it was wrong, but that's good. It was overly defensive, and I want this analysis to be overly defensive, and it worked out well for me. And given the fact that I changed my commits, I changed the behavior changing from the refactoring commits, I can now go back months and I can review refactoring commits from months ago, see if I made a mistake. That's powerful. Limitations. I found some things that I didn't find a solution for now, and one of it is the design and the refactoring. Well, I was trying really hard to do refactoring. I explored a lot, and it often happened that it starts over engineering. For example, when there is the word architect or architecture in the context, it will start over engineering. It's interesting. Something that helped with refactoring is asking it for the responsibilities in the code, do that analysis, and then when it has found responsibilities, to come up with steps how to separate one of the responsibilities. Maybe that worked better. I also found that it is not really good at writing tests or good code, but whenever there already is good code and there already is good tests, it will follow that pattern. So when you have already good tests, a good class, a good test class with good tests, or a file with good tests, it will keep repeating the pattern, and its tests will also be therefore good. And if you have a clean code, it often will also do it quite okay-ish, but usually you might have to do some rework. It's really biased. This is an example. I was working on those slides, and I wanted to make the code bigger, and it thought I somewhat need this extra large variant. I never asked for extra large. I only wanted to make the font bigger. So it wants to please you, and when it wants to please you, it overdoes all the things. It wants large batches. It's hard to get it to small things. I am always right. It thinks I'm always right. It thinks that it is always right. It wants to please me and then overdoes it. And you have to work around those biases. And that's certainly possible with human oversight and giving good feedback, but you have to deal with it. And I also think that it's kind of addicting. Like it feels like it's so crazy. Like you have science fiction on your fingertips, And every once in a while, you get an amazing result, and that's your dopamine hit. And then you get crappy result, and an amazing result. That's your next dopamine hit. So it's kind of addicting. Also, like we want to be right, and it gives us the feeling that we're always right. So that's that. I read this blog post, and I like it. I recommend reading it. The idea is that the problem is it's very easy to get something done with AI, and then it feels like we master it. For example, I am not an expert in writing refactoring tooling with Roslyn, but I could achieve quite a lot of things without being an expert in that field. And it felt good. It felt good. It felt like I mastered this, but maybe I'm only 80% there. Also, when it's so easy to get those things done and get those things to 80%, then it's very hard to pick up the craft again. It's so hard. It's like, why would I do the commit manually? I can have Claude do it. Why would I change those lines? Why would I find out how to do this detail? I could have Claude do it, and it could do all the things. And that's a little bit scary. There are three things that have guided me, I would say, in software development. And those are like, first, make it work, then make it right, and only if we really have to, make it fast. And I bring this up here because I think with AI, it's often quite easy to get the things to work, but it was, at least for me, it was very hard to get the things right. So we're not quite there yet, in my opinion. The conclusion is it's a tool. Maybe it's more than a tool. I don't know. It's very good at certain things, and it's even better at those things that I am. But there are also things that I'm better than it, and it kind of helps me, and sometimes I help it, and it's an interesting way to work. It's like sometimes I feel like the assistant of it, but I think that you should build your own agent. I think it's really easy to do. It's just a couple lines of code, and when you do it, it will clear up, I think, some misconceptions you might have about it. And when you do it, please don't put it in a box of JSON like we do it right now with MCP. I think that using JSON for structured communication with a large language model is heavyweight. It uses a lot of tokens, and we want the fewest possible tokens to keep like the context small. That's crucial. And also, when you use a JSON for example, for code, and coding agents will work with code, they have to encode those multi-line strings into JSON. And then they have to escape parentheses and so on. So it's a great effort to put multi-line strings in JSON, and it's not a good fit for this. So I think JSON is not the best choice, and there are better ways to do this that are easier and more human readable and take fewer tokens. For example, you could use Markdown or pseudo XML, or you could use TOML, TOML, or you can use just like a command line interface, just a few words separated by white space, and that's it. There are different ways to be creative, like about how to have a structured communication with a large language model. Since all of this, and it's so hard to pick up the craft again when you work with agents, but we are still not there yet, and they're not good at design. I think it's still crucial that we learn and practice software engineering essentials, because I think that from my perspective, AI will only amplify what is already there. Like if there is a code base that is not very good, it has no tests, AI will help us make this code base much worse, very, very fast. So it will amplify those problems. But if we are able to have a good code base that is has a kind of high code quality and has good tests, is covered with tests, it will help. It might help us become faster, actually. So I think like getting good with coding with AI means to get good at software engineering, basically. And we have to learn and practice those things in order to be good at using AI. That is test-driven development, refactoring, and design. There are a few books that I would like to recommend that helped me a lot and I found were very good. That is, first of all, The Test-Driven Development by Example, book by Kent Beck. It's already quite old, but it has it's very nicely and easily readable. It's very nicely written and easily readable. Has examples in Java. Then there is the Refactoring book by Martin Fowler. This is already the second edition. It's not that old. It has JavaScript examples. You will learn anything about designs, about code smells, and how and refactoring moves, how to apply them. The Modern Software Engineering book by by David Farley is also a very recent book, and it's very well written and timely. I really recommend it. And Vlad made a really good job in balancing coupling and software design. Like he brought together everything we know about software design, from different types of coupling, cohesion and connaissance and so on, and it formulated everything, brought it together, and came up with a formula like what even is modularity and how to balance a coupling. It's a really great book. Maybe a little bit hard to read in the beginning, but in the end it gets much better. And if you're good at those things, you might not have to read this book. I'm Gregor. I'm a principal software engineer at Tricentis, also a technical coach with the Summon Society, and organizers with the Software Crafters in Vienna. You can find me here. It was a pleasure talking to you.